Every camera movement you're watching right now was designed by me, not AI. You see, camera movement is the thing that makes or breaks an AI shot. And for the longest time, it was the one thing I could never control. I'd see the exact shot in my head, spend my credits, and then watch a random camera drift wreck everything I built. Most people think that's just the price of an AI video. And the best you can do is re-roll until you get that one perfect shot. But I refuse to believe that. So I spent the past few weeks testing every camera control trick I could find, and only 3 actually work. In this video, I'll walk you through all 3 methods, starting with the easiest one, which needs no extra tools at all, and climbing up to the method that finally solved this hurdle for me. By the end, you'll know which of the 3 to reach for to get the shot your project demands. Every video we make today will be generated inside Higgsfield, which I like because it gives me access to the best image and video models in just one subscription. The link to Higgsfield, along with all the tools and prompts used in this video, are all in the description below, so you can follow along as we go. Let's dive in. The first method needs nothing but images. And before we start, I already know what some of you are typing in the comments. Doesn't Higgsfield literally have camera presets built in? It does. And for a standard move, they're honestly great. But a preset doesn't know your scene, and it can't promise where your camera ends up. The moment a specific detail matters, that promises everything. So instead of picking a move from a menu, we're going to define it ourselves, with frames. But before all that, I want you to meet Payak. He's the Muay Thai fighter we'll follow for this entire video. And earlier, I generated a character sheet for him and an environment sheet of the Great Wall. Both are sitting in the prompt pack if you want to build your own. Now, pay attention to the scar on his eyebrow. Keep that tiny detail in mind because that is about to become our lie detector. Now let's continue. The first thing we'll do is the version of this method you've probably already tried, which is using a still as your opening frame. We'll upload an image of Payak on the wall into Cdance 2.0, ask for a slow push in on his face, and set the duration to 15 seconds so the move has room to breathe. Then we hit generate. Here's how it came out. Honestly, the move itself is smooth, but watch his face as the camera gets close. The scar is gone. And that's the weakness of an opening frame on its own. The model invents everything it can't see clearly, and tiny details are the first thing it drops. For simple shots, this is genuinely good enough. But when a detail can't be lost, you need to control where the camera lands, which means giving it an end frame too. Now here's where almost everyone makes the same mistake. They generate their start frame, then generate their end frame separately. Watch what happens when we do that. Right in the middle of the move, the entire background glitches. The 2 frames were made separately, so the wall behind him doesn't line up, and the model panics trying to connect them. That's worse than having no end frame at all. So here's the trick that fixes it for good. We generate both frames inside one single image. Here's how. Inside Higgsfield, we'll hover over Image and select GPT Image 2. Then we'll feed it our 2 sheets from earlier, Payak as the first reference and the Great Wall as the second. Then in our prompt, we'll ask it for one image split into panels side by side. And here's the line that's doing all the heavy lifting. We'll ask it to have both panels share the exact same background down to the pixel, and that only the camera distance is allowed to change. We hit generate, and here's the result. The same wall and the same light in both panels, with Payak dead center. Now our start and end frames align perfectly, so there's nothing left to glitch. So back in Cdance, we'll upload our frame. And in our prompt, we'll load the wide half as our start frame and the close half as our end frame. Then we'll ask for a slow dolly in with subtle breathing, so Payak doesn't stand there frozen like a statue. And notice that the prompt only describes the motion. The frames already carry the scene, so repeating it is just unnecessary. We hit generate and take a look at this. A buttery push in that lands right on his face, with the scar exactly where it should be. But maybe we just got a lucky generation. So let's flip the 2 frames and ask for a pullback instead. And look at that. The camera glides backwards and reveals the Great Wall stretching out behind him like the opening shot of a movie. Same 2 frames, opposite move, and it nailed both. So whenever you need something fast, like a push in or a slow reveal, frames are your method. But notice what we actually did here. We only told the camera where to start and where to end, and the model filled in the road between them. That works beautifully, right up until you need an angle you can't generate a frame for. Try writing a proper over-the-shoulder shot in words and you'll see what I mean. At that point, describing the camera stops working. You have to physically place it. And that's exactly what ShotStage lets us do. It's completely free, and it's basically a tiny film set inside your browser. There's a stand-in character in a simple room, and your only job is to walk the camera to the exact spot you want it. You fly around like in a video game, and once your shot is framed, ShotStage hands you 2 things. A blocking frame, which is a snapshot of your exact angle, and a tailored prompt written for whatever video model model you pick. That prompt is genuinely good on its own. But we want Payak moving, so we'll just weave some movement in. Let's start with a low angle. We click low angle and the camera drops to the ground, looking up at our stand-in. We download the blocking frame and click create in Higgsfield. Inside Higgsfield, we upload 3 things: the blocking frame for the angle, the character sheet for Payak, and an environment sheet for the wall. We tag each one in the prompt. For this one, we'll ask for a slow controlled Muay Thai pose while the camera cranes up and hit generate. Let's watch what we got. Payak towers over us, flowing through his pose as the camera rises. He's finally alive instead of just standing, and every detail is held through the entire move. Now for the real test. Over the shoulder. If you watched my last video, you know this is the hardest angle in AI video because the camera has to sit in one exact spot behind the subject. So just like earlier, we'll block over the shoulder in shot stage, save our blocking frame, and click generate in Higgsfield. In our prompt, we'll ask Dance to generate a scene with Payak seated in prayer. We hit generate, and here's the result. The shot opens on his tattooed back, sunrise blazing through the arch, then the camera slowly orbits around his shoulder and reveals his face. Even that little scar is right on cue. That's true over the shoulder, sitting on the exact spot we picked. And if you want the full deep dive on shot stage, I broke it down in a separate video linked below. Now, I do want to be upfront about one thing. This is the most hands-on method of the 3 because you're placing the camera yourself and tweaking prompts until it's right. That effort is exactly why you get this much control. There's just one ceiling left. Shot stage locks the camera into one perfect position. But even with movement written into the prompt, the shot can still come out stiff. The moment you want the camera to actually travel through your scene, you need to design its entire flight path. So we'll do exactly that using Claude Code and Blender. Now this is the part where most people tap out. They see Blender, they see a setup, and they decide to wait until AI can just do it on its own. Don't. The setup is literally 7 easy steps that you only do once. And to make this whole section easier for you, I left every command I run here in the free prompt pack, so you don't have to worry about anything at all. Keep it open beside this video, and you can just copy each command as we go. So here's how we set this up. Step 1, we install Blender. We head to blender.org, hit the big download button, run the installer, and click through to finish. Just make sure it's version 5.1 or newer, because the official add-on won't run on anything older. Step 2, we install a tiny helper tool called UV. It's the little launcher Claude uses to start the connection to Blender, and it takes one command. We open PowerShell, then we paste the first command from the pack and hit enter. When it finishes, we close PowerShell completely and open a fresh one because UV won't show up until we do. Then we run this quick version check. If a version number prints out, UV is ready. Step 3, we install the Blender MCP add-on. We download it from the link below and leave it as a zip file. Then inside Blender, we go to Edit, then Preferences. From here, we'll click the small arrow in the top right corner and choose Install from Disk, where we select that zip we just downloaded. Then we switch to the Add-ons tab, search MCP, and tick the checkbox to turn it on. If the panel shows a button reading Stop MCP Server, that means it's already running. Step 4, we copy the bridge onto our computer. Back in PowerShell, we run the next 2 commands from the pack, one at a time. The first one just moves us to a clean spot on our C drive. The second one downloads the official bridge files. Step 5, we introduce the bridge to Claude Code. This is one single command, and it simply tells Claude Code where Blender lives. We paste it, hit enter, and that's the whole step. Step 6, we check the connection. We run the last command in the pack, and we're looking for 2 words. Blender connected. Just make sure Blender is open with the add-on running, or the check will fail. And finally, for step 7, we test it. We start a fresh session in Claude Code and ask, what objects are in my Blender scene right now? The moment Claude answers with the default cube, the bridge is live. That's the setup. Finished forever. Just make sure to keep Blender open while you work, or the connection drops. Now, it's time for the fun part. Our first shot is a full aerial drone shot of Payak sprinting along the Great Wall. And here's the tip that makes this whole method click. Get every detail of your shot clear before you type anything to Claude Code, from the camera's height and angle down to how fast it moves. Because tweaking things after is a hassle you don't want to deal with. So let me show you what that prompt actually looks like. It tells Claude what to build. A rough, low-poly blockout of the Great Wall, plus a human-sized stand-in for Payak on the walkway. Then it sets his sprint to a real human pace, about 32 meters over 5 seconds, so the run looks natural. And the camera gets pinned down to the meter, 15 above the walkway and 18 behind him. Every number is clearly stated in there, which leaves Claude 0 room to guess. If you struggle with writing prompts like this, don't worry. The exact prompt I used for this is right inside the prompt pack, so you can tweak it for your own needs. And if that still feels like too much work, you can always ask Claude to write the prompt for you, straight from a plain English description of your shot. So we paste it, hit enter, and this is what we got. The wall snaking along the mountain ridge, the watchtowers, and a stand-in representing Payak. Then it animates the camera to a high drone shot, tracking him as he runs. It even matched his running speed to a real human sprint. And the best part is that we didn't model a single thing. We just pasted a prompt, and there it is. Now we'll save this move as our reference. In the Output tab, we set the media type to video. Then hover over the viewport, click View, and hit Render Play Blast. Blender plays through the move and saves our clip. Then we head back into Higgsfield. From here, everything works exactly like our shot stage workflow, except our reference isn't a frame anymore. It's a whole moving shot. We'll select Seedance 2.0, then upload our Blender clip, our character sheet, and our environment sheet, and tag all three in the prompt. We hit Generate, and just watch this. The camera soars over the Great Wall, sweeping through the morning mist as it tracks Payak sprinting along the ridgeline. That's the exact flight path we designed, and Seedance painted it into a real cinematic world. To be honest with you, the results you'll get from this method are miles ahead of all the others, and it's worth the few extra steps setting this up. I decided to run more scenes the exact same way, and here's how they came out. We have a slow push down the walkway while Payak works through his full Muay Thai arsenal, and a low-angle crane up at the watchtower, where he rises into a flying kick and holds it against the sky. I designed every move myself, and the AI just painted the world on top. The thing I like most about this method is that it's by far the most reliable out of the three. Just make sure that you cover every detail you want starting from the Claude Code prompt, and you'll have little to no issues at all. So that's exactly how to take control of your camera movements, from the simplest method to the most powerful one. Master these three, and you'll never be at the mercy of a random generation again. And don't forget, the links to Higgsfield and every other tool from this video are waiting in the description below, along with the free prompt pack, so you can start using these methods in your own projects. But here's the thing, nailing your camera movement is just one piece of AI filmmaking. Because the moment your characters need to speak, consistent voices and realistic dialogue become an entirely different hurdle, and you'll know exactly how to handle it by watching this video on your screen. Click it, and I'll see you there.